Hello, everyone. This session is enabling about smart warehousing scenario for Industry 4.0 with SAP IoT. My name is Elvira Wallis, and I'll be providing you the bigger picture of Industry 4.0 in the context of this presentation. With that, I'd like to give you the bigger picture of Industry 4.0 and the technology enablers that really advance the data-driven economy, which is what we refer to when we speak about Industry 4.0. It refers to the entire enterprise, from the front office to the back office, involving technologies such as cloud computing, big data management, industrial IoT, edge computing. These various technology, as well as the merger of IT and OT, enable data-driven business processes and enable that we can talk about intelligent factories, intelligent assets, intelligent products, and empowered workers. If we look at these pieces, then we can see that whether it is intelligent asset, the intelligent product, the intelligent factory, or the empowered worker, the information provided, the usage data about the asset, about a product, about shop floor data, as well as the data that empowers a worker, leads to business outcomes that were different if it wasn't for this real world usage data being available. If we look at the example of intelligent assets, you can see outcomes such as increased asset lifetime due to predictive maintenance. You can see field services being more efficient due to adequate dispatching of the technicians. These are classical use cases in the context of Industry 4.0. Next, we will be looking at a smart warehousing use case, and Phil Azanov from Westernacher Consulting will lead you through that use case. Enjoy the story.
Thank you for the introduction, Elvira. So we're going to tell you about an implementation that we did at the world's second largest food and beverage manufacturer of Westernacher's connected forklift solution. So first, we're going to talk about the general product. This is what connected forklift is at its essence. Then we're going to talk about the vision that we embarked on with the customer. And lastly, we're going to talk about our first phase of the implementation. So our connected forklift solution is based on the advanced technologies within SAP's IoT platform. It brings together things like analytics, big data, machine learning, in order to bring a holistic view of forklift operations within a warehouse. Now, our overall SAP IoT portfolio spans the entire supply chain. It includes production, warehousing, yard logistics, transportation, and connected products. But within the connected forklift, it's really about monitoring the position of the forklift within the warehouse, integrating with SAP's warehousing system, SAP EWM, having real-time visibility of the operator's driving performance, and then lastly, improving health and safety of the overall operation in the warehouse. Our solution specifically integrates SAP IoT with SAP Extended Warehouse Management. This enables things like automating warehouse tasks, optimizing forklift operator performance, and also improving the health and safety of operations. This includes the integration of a hardware processor with SAP Edge Processing. This information goes directly to SAP IoT and also is contextualized with information from SAP Extended Warehouse Management. And we're able to interface with a mobile app and also create dashboards in SAP Analytics Cloud. Some key business benefits, like we mentioned, include warehouse task automation, location-based automated booking. So these together mean that rather than a forklift operator having to get out of the forklift and scan a barcode, they're able to automatically confirm a warehouse task with the press of a button based on the location of the forklift. This also reduces training effort And having the precise location of a forklift in a warehouse, you're able to get full operational visibility. This then leads to higher process stability. And as a side benefit, we're also able to improve safety. And so here are some of the hardware partners that we have worked with in developing our connected forklift solution. Many of them use technologies such as ultra wideband and Bluetooth low energy in order to get the precise location of forklifts within a warehouse. And so now we're going to talk about the vision. And so this vision was originally designed using the precise location of forklifts within a warehouse, leveraging ultra wideband technology. The first and more important part of this implementation that we looked at was improved safety. Now, the original kind of project charter, if we're going to talk about it, looked at the recording of events in the warehouse. This could be collisions, this could be an operator moving too fast, this could be an operator turning too hard. But we decided to take it a step further and look at incident prevention. By knowing the precise location of forklifts operators, the forklifts and other workers, we're able to identify risky behavior and near misses, not just when they happen, but we're able to see what leads to it. Is the forklift operator driving faster? Are there certain movements that result in these risky behaviors? Are there certain locations where they happen more often? Based on this, we're able to quickly give feedback to operators. And we're also able to monitor trends. And that ultimately doesn't just lead to recording of high risky behavior, but it leads to the prevention of high risk behavior. And that's really possible because we have the precise location of workers and forklifts. We're also able to intervene in the process itself. So if we have the precise location, leveraging edge processing, we're able to monitor the location of forklifts or forklifts of workers and trigger audio-visual alarms. This really has a lot of potential to then prevent accidents. Similarly, we can also look at near misses or recorded events, and we're able to trigger a workflow that then enables quick identification and resolution and prevention of events. So a warehouse manager can get an email when there is a collision. We're also, for example, able to put lights at the end of aisles that light up when the forklift approaches the end of an aisle. At this point, the light goes off and the worker is warned that a forklift is approaching the end of the aisle. Again, we're talking about prevention rather than just responding to accidents and events as they happen in the warehouse. We're also able to define an operator score. We rate the operator based on their operation of the forklifts. Do they have any near misses? Do they have any collisions? Anything of the sorts? And we're able to identify these risk factors and quickly address them. We're also able to create a heat map. So with the map of a warehouse, we can track where we have near misses, where we have accidents. And maybe it's not the forklift operator's fault. Maybe the warehouse is set up in a way that they are almost encouraged to have risky driver behavior. So for example, if there's a location in the warehouse where the operator tends to drive too fast, we're even able to influence forklift operations, such as decreasing the speed, if we're able to connect to the computer of the forklift. So it's not just about what the operator is doing, but are there parts of the warehouse that encourage risky behavior? Knowing the precise location of where different events and incidents happen enables you to improve operations in your warehouse across operators because of how a warehouse is laid out. This might also mean putting a mirror at an intersection in order to give extra visibility for warehouse operators and workers to see what's going on around them, or a light. And lastly, the most important part is, the worker and the forklift operator. We're then able to ensure that workers stay within the pedestrian paths and out of the way of the forklifts, and we're able to make sure that the forklifts operate safely around workers. So if we see that forklifts and operators are going by each other at a quick rate, we're able to provide feedback and prevent accidents. On top of the safety, we're also looking at process optimization. We are, for example, able to look at operator and worker utilization. We're able to track the movements of forklifts and workers to understand idle time versus movement and see which operators are operating efficiently versus others that are operating less efficiently. We're also then able to integrate with the process. So if we have a WMS, like SAP Extended Warehouse Management, or something like Task and Resource Management, or any other SAP WMS solution such as WM, we're able to contextualize the information that we're getting from the operation of the forklift in order to understand what the operator is doing in context with the tasks they're executing. And this is important because then we're able to understand productive and non-productive movement. So if we go just back to the previous slide, when we look at operator and worker utilization, right here, you can't tell the difference between whether a forklift operator is just driving around or if they're driving around and executing productive work. However, with integrating with SAP EWM or another solution, we're able to record when that warehouse worker is operating at the same time as executing tasks in the system. And so really that's a huge differentiator of SAP IoT as opposed to other SAP IoT platforms because we're able to get that native integration. We're also able to automate processes. So like I mentioned before, by knowing the position of the forklift and the height of the fork, we're able to know which pallet a forklift operator might be moving. Based on this, the operator is able to just press a button and confirm the removal of a pallet from a bin in the racks. This is opposed to then to sometimes, and more often than not, having to get out of the forklift, scan the pallet, and get back into the forklift. So you're getting a lot of operational efficiencies there. This driver app is then able to direct the operator to a staging area. And then we can again automatically confirm the warehouse task once the pallet is placed on the staging area based on that location. Another part that's really interesting to consider here is we can then propose the next task to the operator based on their location to minimize movement and optimize utilization. So this is kind of taking task interleaving or concepts such as waveless picking to the next level. It's not just going off of the source and destination of the different tasks that the operator is executing, but it is looking at their precise location at the moment they're ready to execute the next task. So with this, you're getting improved process automation, improved process efficiency, and a better user experience in executing the work in the warehouse. We're also able to look at forklift operation optimization. So this is more looking at the charging of the battery and minimizing energy consumption by ensuring the driver is operating efficiently. We can see how the forklift operator accelerates and brakes, and if they're accelerating harder and faster and braking harder and faster, they're not only going to be operating more dangerously, but they're also going to be consuming more energy. And this is going to require more charging, more forklift downtime, and it's going to hurt warehouse operations. So even this minute detail, we're able to track by knowing the precise location of a forklift in a warehouse. And lastly, we're also able to look at the forklift path. So there are ways that are more efficient to go through a warehouse, other ways that are less efficient. And so by knowing the precise location, we're enabled to track how the forklift moves to the warehouse and ensure that forklift operators are moving through the warehouse in the most efficient path possible. This means that we're also able to look at congestion areas. So do we find forklifts and pedestrians, for example, are always meeting in certain areas of the warehouse, and that is resulting in slow operation? With this, we're able to redirect forklifts and get them to where they have to be the most efficiently as possible. And now we're going to look at the first phase of Westernacher's implementation of our connected forklift solution at the world's second largest food and beverage manufacturer. First, we're going to talk about hardware selection. And that's important because while our solution works better with different, works with different hardware providers, it works better with some and others. We're able to get certain information from some than others. And I think hardware selection is definitely a big lesson learned from the first phase of this implementation. Then we're going to talk about how we integrated this hardware with SAP IoT. And lastly, we're going to talk about analytics. What did we do with the data at the end? And then as kind of a last tidbit, we're going to talk about next steps. So when we embarked on this hardware selection journey, we first entered with what I'd call a premium supplier, a high-end indoor location tracking provider that used ultra-wideband technology. And that, of course, came with a higher cost. And we came in because we have this vision of improving the safety of warehouse operations and also enabling the future improvement of warehouse operations from a automation and optimization standpoint. And so, really higher cost hardware enables the greater ability to exercise this vision. At the same time, lower cost hardware could potentially get us halfway there, but we also need to make sure that the quality of the data provisioned is acceptable. So, really the selection of hardware has to go between looking at cost, the functionality that it enables, the vision it enables, and then also the quality of the data that is provisioned. And so we ultimately looked at 3 different providers. Connexon was the ultra-wideband provider that was kind of the creme de la creme. It is what the NBA, the NFL, Bundesliga use to track their athletes, for performance, their safety, and now also for COVID. But they are kind of the premium provider of indoor location tracking. The customer also brought in a provider called CarStore, whose expertise was in tracking outdoor trucks for deliveries, but then they adapted their technology for indoors. And I think that's really important to understand that while some providers might be good at one technology, that technology might not always adapt well to other applications. And so lastly, what we're working with is Infolink, which is from Crown, and they are using forklift embedded technology, and they're able to measure impacts and different events. And so again, Connexon open platform, we're getting a holistic view of everything going on in the warehouse based on the precise location. CarStore was something in between, but really because it was tailored to using on trucks outdoors, didn't really adapt well to forklifts. And Infolink is kind of something in between, where the data we got was great, but it doesn't enable the vision the same way that something like Connexon with ultra wideband enables. And so, if we go back to the previous slide again, it's really about balancing cost and functionality, figuring out the right hardware for the vision you're trying to enable. And then it came to integration. And so I think one important thing that we were able to accomplish with this implementation of SAP IoT is enabling the use of multiple hardware providers. Over the course of the project, from the POC to integration with the different providers, we were able to leverage MQTT, XML, and even emailed CSV documents to digest data from the hardware provider. So this included SAP Edge Services and Cloud Platform CPI. One thing that we made sure to do was have a common data model to enable minimal development effort outside of just the base integration. Yeah, so the data is going to flow in slightly differently, but the way we store it and how we ingest it ultimately ends up being the same. And really, that's also largely possible because of the flexibility that the SAP IoT platform enabled us. Lastly, we integrated SAP IoT with SAP Analytics Cloud in order to get analytics dashboards. We created dashboards for driver scores, where drivers were rated based on a scale, and high-risk drivers were identified, low-risk drivers were identified, and perfect operators were also identified. And with this, we leveraged native integration between SAP IoT and SAP Cloud Platform and SAP Analytics Cloud. And so with this, we were able to get the information into SAP Analytics Cloud and enable it in a way that's digestible to the key stakeholders that use this information. And lastly, I want to talk about the next steps. How do we finally execute the vision? Part of this is expanding the information available in Analytics Cloud to provide more information for feedback. So right now we're just getting a score. But as we get more familiar with the data that is coming in from the forklifts, what else can we provide that enables better safety improvements in the warehouse? I think another thing that needs to be looked at is the reevaluation of hardware partners to obtain required information. If you recall, this vision really centered around the hardware providing the precise indoor location, and us leveraging that not just for health and safety, but also process improvements, task automation, etc. And once we also improve the information that we're getting, we can also look at things like integrating with backend systems, such as SAP EWM and SAP EHS. SAP EWM integration enables task automation, enables contextualizing the information that we're getting from the operation of the forklift in the warehouse. Also, things like SAP EHS enable the recording of incidents and events that typically have to be done manually after an incident happens. Here we can automatically trigger that. And so, I think the biggest takeaway here is one, you have to start somewhere. It's about implementing hardware, integrating it with SAP IoT, getting that information in a usable form in SAP Analytics Cloud, and understanding how you can use that information. Based on that, you can then revise. You can change the information you're gathering, change how you're using it. You can get more information. You can clean up the information. You can manipulate that information in a way that makes it contextualized, especially when you bring in things like integration with SAP EWM. But really, the important thing is starting and getting that information. And that is really, if we're talking about enabling Industry 4.0 in a warehouse, it's really the first step. And thank you for joining our session. And if you have any questions, please reach out.